Okay, hello students. Here I'm working on practice problem for homework 3.6, and that is about rational function, right? So we want to know how to sketch rational function. What are the horizontal, vertical asymptotes, and the x-intercept and the y-intercept? So if you see in this case, the good thing is they already gave us in the factored form, and they could have given you this also in the rational standard form, like both the numerator and the denominator are. So if you use the FOIL method of x square and you the last two, if you multiply, become minus 2, and then if you multiply this and this become minus 2x, and this is plus 2x, so this become minus x. And likewise we can do x square, and the last two will be minus 14, but x and minus 7 will be minus 7 plus 2x will be minus. So they could give you also this way, and then for the first step is always factorize. So kind of factorize this. The good thing is they already give us the factors. The question is what are for this rational function, what uh, what are the x-intercepts? So the first thing is, if you see this, how do we find the x-intercept? Is you put, so for the it means the y is has to be 0, right? So that means we need to know what is this. So the best part is put the numerator equals to 0. So you put the numerator equals to 0, so you have x plus 1 and x minus 2 is 0. And then you can clearly see you don't have to write the step. The opposite of plus 1 is minus 1 is 1 x-intercept, or the 0. And the other one is x equals opposite of minus 2 is plus 2 is another 0. So you have two x-intercepts. So they want you to write a smaller one. So if it is a smaller one, the x-intercept is minus 1 and the other one is plus 2, and you're done. That's all they're asking you. Let's move to this another example. This is one. Let's do problem number 2, practice problem. So the second question is also similar one, but they ask you what is the y-intercept. The y-intercept means where the graph crosses here. That means the x-coordinate is 0, and you want to know what is the output. When x is 0, what is y? So all you do is, for this type of thing, you put x equals 0. So here x equals 0, 0, 0, and 0. And you can see the top number will be 1 times 2 is minus 2, 2 times 7 is minus 14, and you can reduce it to negative negatives positives 1 7, and you're done. So that means the graph crosses. Let's see, if this is 1, you break this into 7 parts. So that's 1. That's where the rational function, this whole rational function passes through. That's all they expect you in the question number 2 is checking on whether you understand what is the y-intercept. That's all it is. And we know this from middle school, that what is y-intercept means. When x is 0, what is y? The following question is again the same thing, but this time they're asking you what is the horizontal asymptote. Now, the horizontal asymptote depend on two things. One thing is, for this, of course you don't have to. You can see look up at the coefficient of the x. So there's a 1 here. X is 1. This also is 1. This is 1. This is 1. So look up for what is the coefficient of. So the first thing is always do the ratio of the. So the horizontal asymptote depends on two parts. Is it depends on what is the degree. Right? Just wanted to know. Let's see if there was x raised to m, and the down is, let's put it like a p here, and there's a q here. This is x raised to n. And of course, you may have a lot of stuff here, and you may have a lot of stuff here. The main thing is the degree. So whenever there is a this m is less than n. That means imagine if you have 3x raised to 2, and the down one is 4x raised to 5, and plus something here, something, 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 something. And you can see the degree here is 2 and the degree here is 3. So 2 is less than 3. Then then in such cases the horizontal asymptote is always y equals 0. That's like x-axis. But if it is equal to n, so if it is equal to n, that means I can give another example and say, okay, 2x raised to 5 plus da 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 divided by 4 x raised to 5 da 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 da. Then you just take the ratio, the horizontal asymptote when both the degree is the same. Then it is y equal the ratio of the coefficient of the numerator, that is 2 here, divided by 4, which is half. So that becomes the, and there's another case where this m could be bigger than the n. So if it is greater than n, that means I can put another example and say x raised to 4 plus da 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 da, and then 3x raised to 3 da 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 da. So this is greater than this. So whenever that's greater than, so we say there is no, so y will be equal to the quotient. So that means you have to divide the denominator by the denominator. So the numerator is divided by the denominator. It's like 3x squared plus 5x plus 2. And suppose there's a down is x minus 2, which is degree 1. This is 2. 1 is smaller than 2. So all you have to do is do this, and you can find the oblique 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 asymptote, which is, you can put it like this, and you can use synthetic division or box method. There are a lot of ways. So all this you can do like this. You put 3x, you get 3x squared, and this 3x become minus 6x. If you subtract and plus, become 11x. So what I'm trying to say is that part we'll see later on. What is important is these three things. The bottom line is now in this example, if you see the degree, the top degree, so the numerator, this expression, remember it is x squared minus x minus 2, the down one is x squared minus 5x minus 14. So there's a coefficient is 1, the leading term, and in the leading term for the denominator 1, 1. So, and the degrees are 2. So the degree, this is, when the degrees are same, you just have to write y equal the ratio of the of whatever this is a and b. The right now it is 1 and 1, so 1 and 1, so y equals 1. So this asymptote is 1. I hope that makes sense. Now, so the function here R has, so we need to know what is vertical asymptote. That means sometimes the graph is, let's say, 1 over x is the parent function of the rational function which goes this way, say. So this one goes as x becomes very, very, very large. You can say as x approaches a very large positive number, the y almost becomes 0. See, that's the end behavior. But on the other side, then here you can see here. So if you see, and on this side, when x approaches very large negative number, y approaches also negative. This is almost touching this, see? And then the graph goes down to minus infinity. It means when you approach the 0, what is vertical asymptote is when you approach 0 from right side, that means when you approach to 0, that means x approaches to 0 from right side means positive numbers, you put plus, and the graph goes on increasing. That means, okay, y is plus infinity. But when you approach to 0 from left, let's say it's like minus 0.001, something like that. So it's very small number, maybe here. So this side, when x approaches to 0, and put a minus here, and y approaches to minus infinity. It means the output becomes very, very large negative numbers. So the best way to learn is how to find the vertical asymptote. Just put the denominator equal to 0. We don't want the denominator to be 0. So this denominator is x plus 2 and x minus 7. And when you put it equal to 0, you're asking for what value this will work, which is when this x has to be minus 2 and this x has to be plus 7. You're done. That's all they're asking you. Y equals minus 2. So the smaller one is minus 2, you put here. sorry, x equals, I'm sorry, this should be x, x equals -2 and x equals +7. So this plus is +7 and you're done. It means if you see the x-axis, this is -2 and 1, 2, 3, 4, 5, 6, 7. So there is a vertical asymptote is usually denoted by dotted line, like something like this, and this one. And if you see the earlier one, I forgot what was the y-intercept and the x-intercept. So the x-intercept was opposite of the numerator when it is going to be 0. So -1 and +2. So it's like, so here -1 and +2. So these are the places where the graph crosses the. And when you want to know what is the y-intercept, you put it at 0, and we have seen it's like -1. I forgot two. I think +2, 7. So somewhere here maybe. And later on, you will see how to graph. This is such a beautiful graph. You can see when you take something 8 here and you put an 8 anywhere here, so the whole thing becomes positive. Means the graph goes something like this. Approach this to the right side. The behavior here is like this, and go. There's a 7 is the vertical asymptote. Now this is how you will see the graph goes something like this. And on this side, if you see, if I put this is -2, and if I put plus -3 in the whole thing, and you'll see it's going to be positive. So it goes like this. And all this, don't worry about it. We'll see the next. Uh, okay, the question is here. Find this. Okay, students, yeah, I'm working on, let's see another problem number 5, practice problem. So here the questions are find x-intercept and the y-intercept of the rational function. So the function is given here, and you can see this is 2 divided by x squared plus 5x and -3. And if you see this, we need to know what is the x-intercept. How do we figure out the x-intercept? We want to know, suppose I write y, you need to know when is this whole thing becomes equal to 0. It's like we want to know where x the graph crosses. So in order to do this is the numerator itself is 2, and this 2 will never become 0. So here we see it does not exist. So there is no, the graph never crosses the x-axis. Then what about the where the y-intercept? Y-intercept is 0 and y. So we need to plug in x equals 0. So that means you just want to know when is the. So in the equations to x square, you plug in x is 0. So if I plug in x is 0 here, so this will be 0. So 0, and this is going to be 0. So you end up getting 2 minus 3, which is -2/3. So that's -2/3. And that completes those are the only two questions. Let me go to next question. Uh, let's take one more example and problem number 6. Fine. Now, in this rational function, the question is what is x-intercept? So how do we find x-intercept? So this is the numerator, this is the denominator. So for the x-intercept, you put the numerator equals to 0. That means x squared minus 4 equal to 0. And if you add for both sides, you get x squared equals 4. And then taking square root both sides. You just cannot take square root, you have to put plus and minus. So your answer is -2 and +2. So this is the smaller one which you put here. But remember, you have to put x and y. So it is -2, 0. And the bigger one is +2, 0. And how do you find a y-intercept? To find it's like when it is 0, and when input is 0, and the independent value is 0. So what do you get? This question mark. So you plug in x equals 0 here, and you can see it looks like it becomes -4/0, and this -4/0, and this we say does not exist. So all you do, you put a D and E, and you're done. Let's do another practice problem, and that's problem number 7. So the question is, what is the x-intercept? What is the y-intercept? And also you need to know what is the horizontal asymptote, and what is the meaning of vertical asymptote. So these are the things. So by just looking at it, we know to figure out x-intercept, you can see it crosses here. So it is 1, 2, and 3. So this is 2, 0. So that's the x-intercept. And you see there's only one x-intercept. The graph is crossing the x-axis only once. And the y-intercept also, there is a here 3, 1, 2, and 3. So this is 0, 3. So the graph crosses the y-axis at 0, 3. So this is done. Then what is the meaning of horizontal asymptote? You can see this blue dotted line here. This blue dotted line. This blue dotted line is the horizontal axis. So if it is horizontal, what is the equation? And horizontal axis will be always y equals and to where the number crosses. And you can see the number. This is the 2. So the horizontal asymptote is y equals 2. Sorry, y equals 2. And what this means is as why it is the horizontal asymptote is y equals 2 is because as x, you can see when x approaches to a very large positive value, so the y value, the graph or the output, you can see almost the red color is the output, and this is almost going to touch. It's almost going to touch, but it's not going to actually touch. It's going very close towards the x-axis. So the output is almost equal to 0. So we say almost tends to 0 or approaches to 0 positive. So I'll just put positive 0 there. So this is positive, or just put a 0 also. So y approaches to positive. Then and the same thing on the left side, if you x approaches to a very large negative number, the output, the graph, can see this graph also approaches to, sorry, so I made a slight mistake here. The y is not, the y is 2 here because this is 2, right? So y is 2. I'm so sorry. So this graph approaches to y. This graph touches the horizontal line, and that's why I say y is 2 is the horizontal asymptote. Now, what about vertical asymptote? So the vertical asymptote is where the denominator, the denominator, you want to check whether the denominator is 0, and you can see this one is undefined at 3. So this is 1, this is 2. And you can say at x equals 2, the function is undefined. So whatever the function, rational function is undefined, that means if you subtract 2, you get x minus 2. So it's like the denominator is like x minus 2, and that's where it is undefined, or there's a vertical asymptote. So the vertical asymptote is the vertical line. So the vertical line, the blue dotted line, which is x equals 2, and that's it. You're done. And what it means is if when x approaches, so this basically this has a nice meaning here. When x approaches towards 2, to the right side of 2, that means I'm going to write here x in this highlight. X approaches to 2 from the right side, that is raised to the plus 2. What happening to the y is y, you can see this y goes down and down, so the output becomes very large negative value. So that's what this means. And on the right side, if x approaches to 2, that means when x approaches to the left side of 2, which is minus 2, and then we can say here the y, the output, they're going on increasing, see up, so to plus infinity. So this approaches, and that's why we say there is a vertical asymptote at x equals 2. Hope I made sense. Okay, let's do problem number 8. Find all the horizontal and the vertical asymptote if there is any. Now to find the vertical asymptote, all you do is you want to know let's say if there is a graph and you want to know vertical asymptote like this, or you want to know where it is. So all you do is you want to know where it is undefined. So let's say if this is 3, then you say, okay, the down one has to be x minus 3. Now, if you look at the down here, you just put the denominator, put it equal to 0, and figure out when it's going to be 0. So this means x minus 5 is 0. You add 5 both sides and you get x equals 5. And that's the vertical asymptote done. And remember, there is a domain also. Now, if the question is asked, they did not ask here, that the domain is from minus infinity. You at 5, you see there is a dotted line. So that, let's say this is 5. So it is undefined at 5. So you put from minus infinity until 5 and then union and again 5 to plus infinity. This is the domain here. And then the question is, what is the horizontal asymptote? So what is, how do you know where the graph approaches to a certain horizontal line? So that means there will be some horizontal line. If there is it here or is it this one? So is it this or is it the y axis, the x axis, or is it negative? So we want to know, or maybe it is a oblique line like this, slant asymptote. So that's what our goal is. And how do we figure out that answer is all you do is for the horizontal, so you look up for, now if you see the top part, it means it is 9x raised to 0 and the down one is x minus 5. So look at the degree here is 0 means it's constant and the degree here is 1. And remember whenever this, if I call this as m and I call this the down one is n, and when m is less than n, the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is always the x-axis. So what I mean is, okay, let me write this, and here it is. So it means it is basically it is 9 and x minus 5. If you want to really understand the conceptual understanding, it's like there's a x, so you divide by x all these places, and you get 9 over x and divide by 1 minus 5 over x. See? So, and as you make x a very large positive number, let's say very large, so this denominator, see this denominator, if I have something like 1 over 10, that's 0.1. That's 0.1. If I write 1 over 100, that's 0.01. If it is 10,000, that will be 0.0001. So this number almost comes closer to 0. That's why we say, hey, the top one is almost goes to 0. So this is like almost 1 minus 0 and 0. That means the output, this y equals is almost ends to 0. That means the equation of the horizontal asymptote is, we say, hey, it's y equals 0. That means it is the x-axis. The equation of x-axis, even though it is a main x-axis, but it has an equation and it is represented by y equals 0. That's because any point you take, the y output is always 0. You take here, the output is 0. So y equals 0. And I showed you how it is. Let me go to problem number 9. So here the question is asked, what is the horizontal and vertical? Again, another situation here. So does it has a vertical asymptote? How do we know a rational function has a vertical asymptote? You just have to put the denominator equal to 0 and check for what value of x will that work. So 16x squared plus 1. Now the question is, can this v ever become 0? Because there is a x squared term. So if this is x squared, this will be always positive, and you are adding 1 to it. So this will be always positive. The denominator is always, so there is no vertical asymptote here. You say does not exist. And to figure out the horizontal asymptote here, so the numerator is 5x plus 1, and the denominator is 6x squared plus 1. Clearly check for the degree of the numerator. Here it is 1 and here it is 2, and the bottom is greater than 1. That means the the denominator degree, if it is bigger than 1, straight away you say, hey, y equals 0. The x-axis is the horizontal asymptote. And you are done. That's all it is. So in other words, if you really want to understand conceptually, it means all you can do is, suppose this is the equation and divide. Here the highest degree here is 2. So all the terms you're going to divide by, x squared. So you divide x squared, x squared, x squared, and x squared. And what you get is you get So this will be 5 over x here, then plus 1 over x squared, and the bottom will be 16 over 16 x squared over x squared, and then plus 1 over x squared. So it's like you're dividing, right? Oh, I already did this. So I don't know. Okay. So I think I should have just taken this off because that crosses out. So this x squared crosses, and you left with that. And you see there's a x here. The top part will be 0. So this approaches to 0, 0, 16 plus 0, which is 0. So that's why we say y equals 0 is the horizontal asymptote. It means the graph, the down one is, if you want to really see how the graph is, you put 0. So if I put a 0, you want to know what is the y-intercept? That means you will see it goes like this. Okay, and then it never touches the, so if I put x equals 0 here, you get, so the graph crosses, let's say this is 1. So I'll just make this as 1. So maybe this is 1. And if I put the numerator equals to 0 to check what is the x-intercept, so numerator becomes 0 is 1 equals 5. You can use directly this. X becomes minus 1/5. Maybe if this is minus 1 and minus 1/5, like this. So the graph will be, it goes through this, and remember, it has an x-intercept and does not have a vertical. So it means it may go up something like this. And finally, as x becomes very large positive, the graph may be going very closer like this. See? And the same thing may be going down, and you can always check with the help. So this is how the shape will be x-intercept, y-intercept, x-intercept, and the horizontal x-axis is this one. So it approaches on either side. You can see the graph approaches to x equals 0. And I hope, so the horizontal intercept is, sorry, y equals 0. So y is 0. That's it. Okay, now there's another question number. Let's see question number 10, practice problem. Find the intercepts and the asymptotes. So you have to find this two and all of them and then sketch. Now, first thing, let me do what is to find the x-intercept, this one, you have to put the numerator becomes equal to 0. And clearly this one will be, you can work it out, and if x equals 1. So that is x 0. So this becomes 1. So this is 1 comma 0. How do you find the y-intercept? To find the y-intercept, you put x equals 0. So if I put a 0 and a 0 here, you get minus 8 over 2, which is negative 4. So this becomes 0 is negative 4. And then what is vertical asymptote? For the vertical asymptote, you put the third step. To find this one, you have to put the denominator is 0, and you want to check when is that works. When is this going to be 0? And the only option is when x equals minus 2. So you just write this is vertical asymptote. And to find the horizontal asymptote, you check the degree of the numerator and the denominator. And if you see in the rational function, both degrees are 1, 1. It means when this happens, all you do is, let's see, if I call this P and there is a X and M up here, the leading term, and the Q here, X is N, and you have blah, 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 something. We are not worried. So the leading term matters to decide what is the horizontal asymptote when they have the same degree. So degree is 1. So that is the 8 is the P is the 8, Q is the 1, or 1 time. So the horizontal asymptote is y equals p over q. That's all it is. So the p is 8 and the q is 1. So that's 8. So this is y equals 8. And then you need to also sketch this. So now that I have all this information, how do I sketch? Now to sketch this, so what I'll do is draw x-axis and the y-axis. So this is the x-axis. Let me graph this one. And this is x-axis, y-axis. Then let's mark the x-intercept. So x-intercept is, let's say this is the one. That's x-intercept. Y-intercept is minus 4. So this is 1, 2, 3, and 4. So that's negative 4 right there. Sorry, the x-intercept is the 1. So the y-intercept is 0 minus. So I say 1, 2, 3, and 4. So that's where the graph crosses. Then it has a vertical asymptote at x equals minus 2. So I'll have to go, this is minus 1, and this is minus 2. So that means this is going to be the vertical asymptote. And the horizontal asymptote is y equals 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that's it. So the vertical asymptote is this one. So it goes through this. So how does the graph look like? Now remember, to sketch this, the I need to now the question is the if I try to draw y-axis, this goes up like this. Now if I take anything greater than 8, look at this. This basically is 8x minus 8. Always better to factorize. So if I try to put anything x bigger than, that means to graph this, you also should know what are the main points here. When is the denominator equal to 0? When is the numerator equal to 0? And that's how we can break the whole x-axis. So the main points are this part. See this part -2. So we want to know from minus infinity -2 where is the graph, and then here, and then from -2 till 1, and then 1 to plus infinity, because that's the domain. Because 1, sorry, here 1 is included, so that part is 0. So this point is part of it. So I'm going to say close. This is an open circle. This part, this is open. Now, how does this? So let's see if I put anything x, which is. I'm sorry. This should be. Let me take. This is 1, because when you pull out, so this will be 1, right? Okay, and you can see I already shown that there's a 1 here. The graph has to cross. Now the question is, what if I plug in anything bigger than 1? Let's see. So then the number line, if I put 2, if I put this 2 right here, 2 and 2, and you can see we want to know whether it's positive or negative. And you can see the top will be positive, the bottom will be positive, so it has to be positive. So naturally the graph has to also pass through. So let me take this off now. You already know the answer is going to be positive. So this has to be, see that it has to cross this also. So naturally and the horizontal asymptote is y equals 8. So this side it approaches to this, and then it has to go this way. See? Okay. So then what about in between the two? So it has to also cross to -5. I think that's the one I have to show here. So this part is -1 because the y-intercept is -4. So it has to go through this, right? So this something like this. It goes like this. This is how it will go like this. So you can check which one works. Of course, mine thing is not beautiful. It's like this. This should have been better like this. So that would be better. Goes this way. And then if I pick anything to the left of -2, let's see if I plug in -3 over here. If I put -3 and -3, and you can see this will be negative, the bottom will be negative, and two negatives makes it positive. That means the graph has to be above. So if it is positive, and again, should I go start from down? Will this help? This will make it negative if you go down. So this won't help. So all you have to do is it will have to go up on the top side. So that means I will have to go starts here and then goes closer to. And you can always plug in the value. If you want, you can plug in two values, one with -1.009 or 001 in the equation and see what's going on. And or you can put one on the left side of -2 and see what's going on. But like when I say here, you can put -1.01, something like this. And you will see that will be very large positive number. That's what I'm saying. But if it is this one, then it will be very large negative going downwards. Hope that helps. and then you can figure out which is the right graph. I know it is shabby. I know I did not do a good job, but as long as you understand what is important, it crosses. Uh, it has a vertical asymptote. It has vertical asymptote. It has a horizontal asymptote. It crosses the x-intercept. It crosses the y-intercept, and then you can figure out by plugging some numbers to know how the graph will look like. And I did forget to write what is the domain and the range in this problem. See, so the domain here would be, remember there was a dotted line. So this is the dotted line we should avoid. So it means from negative infinity all the way to -2 and union -2 to plus infinity. And the range, see, look at the range is the graph goes down all the way goes up, but there is a break right here. You can't have y equals 8. So the range is again from down minus infinity all the way up 8, and then union, and then goes up. See, so there is a break at to 8 here. So 8 to plus infinity. So hope that helps. Question is find the vertical. Sorry, this one is. This example, they are only asking what is the vertical asymptote. So you just look up when the denominator is 0. So the denominator is 0 when these two parts equal to 0, and you can use zero product property that either x minus 6 is 0 or 8x plus 9 is 0, and you solve for this and you get minus 9 over 8 is one of them, and we add 6 and you can see that x equals 6 is the answer. So when you are putting here, you're going to write down x equals 6 and then put a comma and write x equals minus 9 over 8. This is how you're supposed to write. And what is the vertical asymptote? Horizontal is, this means if you look at the degree, the top part, there is a number 1 times and this is 6 times. So 1 times 6 becomes 6 and 1 times 8 becomes 8. So this is like P over Q form. Why am I using this for the horizontal asymptote? Is because the degree, the top part, if you use the FOIL method, you get minus 6x and minus 7. And if you use the second one, you end up getting plus 3x, you can check, and 54. So that means, can you see the degree is 2, both up, down, and that's why we use this formula and you get the answer as reduce it to 3/4. So here you're going to write y equals 3/4 and you're done. Okay, so this let's do question number 12. So you're given a rational function. What is the x-intercept? So remember x-intercept, we can clearly see the top part becomes 0. The numerator when it is minus 6, so this becomes minus 6 comma 0. The bottom part helps. The y-intercept is when you put x equals 0. So if we put x equals 0, this is 0, this is 0, and this is 0, and you end up getting minus 6 over 7. Okay, so that means this will be 0 minus 6 over 7. And what is vertical asymptote? For this, you need to know when is the denominator equal to 0. So the denominator is 0. These are the denominator. You just do the opposite. Opposite of plus 7 is minus 7. So that you can write is x equals minus 7 is 1, and put a comma, and the other one is do the opposite of minus 1, x equals plus 1. And how do we find horizontal asymptote? You can clearly see this is that the degree of the numerator is 1, but the degree of the denominator is 1 plus 1 is 2. So this is the degree of the numerator is smaller, because when you multiply this, you get x squared plus 6x minus 7. So the top degree is smaller than the bottom. So the whole thing becomes y equals 0. Straight away, you write y equals 0. And if you want to graph, let's say if we need to graph this, so we need to know is the main thing is the vertical asymptote is minus 7. So I have to take, maybe this is minus, not a perfect. So minus 7, and maybe 1 is somewhere here. So these are the two places where there is a vertical asymptote. That's the vertical asymptote. And you can see the graph, and the graph crosses. What is the x-intercept? And you can see the x-intercept here is minus 6 comma 0. So somewhere here, that's minus 6 comma 0. And the y-intercept is minus 6/5. So it means if I try to write -1 here and -2 somewhere here maybe, okay, and then the sketch will be, you can easily see that if I take anything greater than 1, let's say put it over right here, will be always positive. So it has to be, and the horizontal asymptote which we forgot is y equals 0. So that means it has to go something like this. So this is the graph. And also to the left side, you will see this side is to the left. If you put a 0, you can see that it is negative -6. So the graph goes this way. And then here, to the right, it will be negative, but to the left, between here, it goes up like this. And then if we take anything -8, it will be this one. And I hope that helps. I will stop this problem number 12. And there is more that 12, 13, 14, 15, 16, 17, I will do separately. So see you guys, and I hope you will continue with your Cengage homework with these practice problems.